All right, so yesterday we looked at some of the kind of boring graphs, the lines and the circles. We're going to look at some of the cooler classic polar curves today. And this graphic organizer, we're actually going to spend quite a bit of time on this because we're going to label a bunch of stuff on this. This is something that you're going to come back to and be able to refer to. So make sure you get all this stuff written on there well. Once you get into calculus and you're doing polar, or you're in some other math classes where you're diving way deeper into polar than what we're doing, these would be things you would be expected to know, like look at the equation and know what it is. Right now, it's brand new to you. Nobody expects you to just know that. So make sure that you have it labeled and you can refer to it and you can figure it out. And I'm going to help show you how we're going to figure things out, okay? So bear with me as we go through this. Don't be freaking out when we do the first couple and you're like, how the heck am I going to use this? Once we get through the whole thing, you'll feel better. And then once we start actually answering some questions and using this, you'll feel better then too, okay? So let's get started. I'm going to make this a little bit bigger for you. Okay, so we're going to start in the first column, which is circles, which is what we did yesterday, okay? And we actually wrote down these rules where if you have a cosine theta or a sine theta. And I also want you to, so if it looks, what it looks like on here, you have like an x and y axis. And it's fine for you to think about it as the x and y axis. On the polar coordinate system, you technically just have the polar axis. However, your brain's going to think about x and y axis whether you want it to or not, because that's what makes sense, and that's fine. Because remember, we could graph this on the x and y axis, or we could even think about them as being overlaid on top of each other. So I can think about what I'm doing in polar, but actually still kind of think about having an x and y axis 100% fine, okay? Because then I think it makes it all make a little bit more sense to you. So what we knew yesterday is that if it's cosine, then our circle would be split by the x-axis. If it's positive, it's over here. If it's negative, it's over here. If it's sine, then it's split by the y-axis. It would be up here or down here, okay? So if I have r equals a cosine theta and a is greater than 0, that means it's positive. That's why I'm over here. These are all just examples. Everything's generic on here, but we're going to write down, we're going to come up with these specific equations for these specific examples, just so you can see how you need to do that, because that's one thing that we're going to have to be able to do. So if I look at this, this is 1, 2, 3, 4, 5. That's my diameter. That's actually what A is, correct? And since it's 5, this specific circle, this is the generic version, but it is r equals 5 cosine theta. Make sense? Just like yesterday. Okay, so then this one, it's on the x-axis, but it's on the negative x-axis. That's what makes a negative. So this would be, this is still a. This would be r equals negative 5 cosine theta. Oops. Okay. Then we have r equals a sine theta. So sine, it's on the positive y-axis because we associate sine with y. And this again is a. And this again is 5. So this is r equals 5 sine theta. This is still a. It's on the negative y-axis. That's how I know it's negative and that it's sine. So r equals negative 5 sine theta. How are we doing? We good so far? Just total review from yesterday. Now let's look at the next column because this one gives us some cool graphs. This category is called Limisons. It's a limison. That's a funky C. Anybody know what that C is called or what the thing on the C is called? It's in some language. I only know English. I'm very limited, so took 3 years of French. I know none of it. Maybe some of the bad words, but that's about it. Okay, so for a limison, the format of the equation is r equals a plus or minus b cosine theta. So this part looks very much like this, but basically we're adding or subtracting another number to it. In the xy coordinate plane, that would be a vertical shift up or down, right? Totally not what's happening here. Totally different in the polar system. But I do know that it makes it not a circle. But of all of them, it's only the limisons that have the plus or minus when r is just r. And it does say that a and b, they're both positive. Okay, A and B are always positive. And whether or not this is plus or minus, so for instance, this is on the positive x-axis, so I know that it's cosine, and it would have to be plus. If it was minus cosine, then it would be over here. Okay, so if it's the minus, it puts it on the negative side of whatever it is you're doing. Okay. Another way, so if we have what's called a limison with an inner loop, so loops inside of here, then A over B is less than 1. Another way to think about it, the way I prefer to think about it, is that means that A is less than B. It's the same thing, but to me that makes a little bit more sense. So here's how we use the A and B to come up with what our R values are here. So from the pole to the very outside, the biggest R value we can have, we figure that out, that's A plus B. To figure out the maximum R value for the inner loop, this is going to be B minus A. Okay, cannot see what I wrote there. Hang on just a second. There we go. B minus A. So you add them to get the big one, you subtract them to get the small one. Don't stress out too much about whether it's B minus A or A minus B. Take the bigger one minus the smaller one, and that'll be B minus A if you have a limison with an inner loop. Okay. So we have to figure out what A and B are in order to write this. So the A plus B is 1, 2, 3, 4, 5, and B minus A is 1, 2, 3. So I need two numbers that are going to add to give me 5, but subtract to give me 3. What do you think those are? 4 and 1, okay? And 4 and 1, and it's fine just to reason through it, and then last period I had somebody say, how the heck did you come up with 4 and 1? Well, you only have so many numbers that are going to add and subtract to give you 5 anyway, right? So you can just kind of play with the numbers, or you can do it algebraically, and everybody's brain works differently than somebody else, so I want to make sure you understand what we're really doing here algebraically. A plus B has to equal 5, and B minus A has to equal 3. So it's a really simple little system of equations. I can make this into B equals A plus 3, right? That's what this becomes. Then I can substitute it in there and get A plus 3 equals 5. So 2A equals 2 means A equals 1, and then I can figure out B. Okay, so algebraically, that's what's happening. But again, you only have so many numbers, you can kind of play with the numbers and figure it out too. It doesn't have to be some crazy algebra problem, but that's what's actually happening there. Okay, so that means it's 4 and 1. And which one is A? Is it 4 or 1? 1. And we know that because of this right here, right? Figure out the numbers, and then we can worry about, all right, so it's R equals A. A is less than B, so that's where my 1 goes. This is on the positive x-axis, so it's plus. 4 is the other number. Since it's on the x-axis, that makes it cosine theta. That's how I come up with my equation. So we're going to have to do a couple different things. Have a graph come up with an equation, or have an equation and match it to a graph, knowing how A and B are related. Okay, are we good? Okie dokie. So then we have what's called a cardioid. Looks like a heart. Cardiac, cardioid, that's why it's called a cardioid. There you go. There's your prefixes. Here, A equals B, or A over B equals 1, which is the same as A equals B. And so the cardioid is always going to be right here on the pole. So from the pole to the biggest part, the maximum R value you can have is going to be 2 times A. Or A plus B, it's the same thing, but I think officially it's 2A. So I know this is going to be R equals. This distance here is 1, 2, 3, 4, 5. So 2A equals 5, which means A equals 5 over 2. Right? Do you think it's going to be plus or minus? Minus, because I'm on the negative y-axis, right? So this is minus. The B is the same number, 5 halves. Is this sine or cosine? Sine, because it's on the y. This is sine theta. Okay. So do you see how to process through that, even though these are brand new graphs from you? We're using the generic and just taking what we know and substituting it in. Okay. Any questions at all?
Can you re-explain how you got 5, 2?
Yes. So this length from here to here is 1, 2, 3, 4, 5, right? So that means that 5 equals 2a. That means that when I divide by 2, a equals 5 over 2. Does that help?
How'd you get 2a, miss?
Okay, that's the rule that I'm giving you. Does that make sense? Just like I'm telling you that this is what the equations are, and I'm telling you that this is how they're related to get this. So this is just the rule that we're labeling on there, and it's always true for a cardioid. Okay, does that help? We good? Anything else? Kinda.
So when you use 5, are you just putting an example into the rule?
Basically, I'm putting this specific example. Because if this was just a generic thing, then if I didn't have a grid, I wouldn't be able to come up with anything, but they gave me a grid, so that's where I'm getting 5 from. Yes. So this is on these, this is the generic thing, right? And then this is the one that's specific for this circle. For the cardioid, this is your generic, and then this one is what is specific for this specific cardioid. Does that help? How I got 5? I counted. Does that help? Ask me something else again, or ask it different if I'm missing something. Okay. Okay. So then we have a dimpled limison. So I'm going to give you the rule again. So I'm telling you for a dimpled limison, A over B has to be between 1 and 2. Another way to look at that is that A is between B and 2b. Okay, those make a little bit more sense to me, but if this makes more sense to you, then it's fine. It doesn't matter. They're the same thing. Here's how A and B are related for a dimpled limison. From the pole to the farthest point, this is A plus B. So if you notice the difference between a cardioid and a dimpled limison, the pole right there has a point from the cardioid. When this point starts to pull away from the pole, it turns into a dimpled limison. So now we have a space here. This space here is A minus B. So you add them to get the big part, you subtract them to get the little part. So I know this is, again, is going to be R equals A plus or minus B times cosine or sine of theta. So for this specific one, R equals, okay, so now I got to figure out A and B again. This time I need two numbers that add to give me 1, 2, 3, 4, 5, and subtract to give me 1. So what two numbers can I add to give me 5 and subtract to give me 1? 2 and 3. Okay, so my numbers are 2 and 3. Is A going to be 2 or 3? 3, because A has to be bigger than B, right? So that's why this makes more sense to me than this. So A has to be bigger than B, so A is going to be 3. Is this going to be plus or minus? Minus, because it's on the negative y-axis. My other number was 2. I'm sorry, negative x-axis. My other number was 2. Is this sine or cosine? Cosine, because it's on the x-axis. This is cosine theta. This would be plus if it had been facing this way. Okay? Okay, so I just saw some stuff pop up in the chat. Remember, the only thing I want in the chat, I mean, you can put stuff, I don't care, as long as it's appropriate, but I'm not going to see your questions. So please, please unmute and talk to me. Don't be afraid to do that. But in the chat, I do want your first and last name. Don't forget that either. But please ask the questions, because I'm not looking at that all the time. All right, we good on dimpled limison? All right, so then we have a convex limison. So if this keeps pulling away and it's no longer dented in, becomes flat, it kind of looks like a circle, but it's not. And that was the other thing that you could have chosen on your little graphs that's really not a circle. And that's what a convex limison is. Here, this Again, from the pole to the biggest part, this is A plus B. From the pole to the smallest part, there, that is A minus B. So it's the same idea. You add them to get the big one, you subtract to get the little one. It's actually true on all of them. Add to get the big one, subtract to get the small one. And so what this would, another way to write this would be that A is greater than or equal to 2B. I know since this is in the Limison category, it's going to be R equals A plus or minus B times sine or cosine of theta. So I've got to figure out my numbers. I need two numbers that are going to add to give me 1, 2, 3, 4, 5, and subtract to give me 3. 4 and 1 again, right? What is A? Is it 4 or 1? It's 4 this time. It was 1 the first time. It's 4 this time because it has to be bigger. So I get 4. Do you think this is plus or minus? Plus, good, because the big part is up here on the positive, plus. My other number was 1, so I don't really have to put it. And then is this sine or cosine? Sine, very good, because it's on y, sine theta. What questions do we have? We good? Okay. Anything about Limisons? Okay. So our sine cosine rules, you know, about whether it's laying on the x, laying on the y, changes a little bit with the roses, okay, which can kind of make things a little confusing sometimes, I know. But so if you have a rose, notice we don't have any plus or minus anymore. It looks very much like a circle. The difference is it's not just theta, it'll be 2 theta or 3 theta. So if you have a number right before theta, it's not a circle, it turns it into a rose. The number of petals the rose has depends on whether or not this number is even or odd. If this number is odd, that's the number of petals it has. If this number is even, you have to double it. That's what this says here. That's why here, this is 3, so it has 3 petals. 3 is an odd number. This is 2. It has 4 petals because you have to double it since it's even. Okay, that's your rose rule there. Okay, so let's look at these. So here, I know that n is 3. That's why we have 3 petals. Your maximum R value is from the pole to here, and that's A. Okay. Whether or not it's sine or cosine, you look at the first petal, and somebody asked me a very good question last period, how do you know which one is the first petal? Well, you look at the one like closest to 0, like if you were rotating. So this first petal is on the x-axis. Since it's on the x-axis, that means it's a cosine graph. I know it says that it's cosine, but like if it didn't say that at all, that makes this a cosine graph. Okay, does that make sense to you? That's how we know that. If it was a sine graph, so you might want to draw this over here. If it was a sine, I'm going to draw a little one, and it's not going to look real pretty, but it would look something like that. This would be sine theta, sine of 3 theta. Notice how for the sine of 3 theta, it would not be on the positive y-axis as you might expect. Instead, you look at that first petal. It's not on the x-axis, but it's in the first quadrant. That's what makes it sine. And that really sometimes is all you need in calculus to know, oh, first petal's in the first quadrant. We wouldn't have to draw it. We don't care what A is, like just having a concept of where things are based on your equations. But that takes some practice. You start at 0. You start at, just like you would rotate around the circle, you go 0, pi halves, pi, 3 pi halves. So you start here at 0, and if there's not a petal here, then you start rotating, and when you hit that first one. Does that make sense to you? It's just the first one you come to in your rotations. Does that help? Yeah? Okay. All right, so that makes this, since this A, this is my generic one, but this is specifically 1, 2, 3, 4. So this equation would actually be R equals 4 cosine 3 theta. All right, so let's look at the next one. Here, n is equal to 2, but we have 4 petals because it's even, so we double it, right? Your maximum R value, which is your A value here, is still from the pole here. So that's good. That doesn't change or get anything weird. So here's where, when you look at this, I look for a first petal. There's not one on the x-axis. The first petal I come to when I rotate is in the first quadrant. That's what makes it sine. If I rotated it pi-fourths, like if I had one on the x-axis, I would also have one on the y-axis if there's 4 of them. So that's why you can't really use that rule. It doesn't work for the rows stuff. So cosine, it's not cosine, so it has to be sine. So again, this is 1, 2, 3, 4. So this is R equals 4 sine 2 theta. When we look at the next one, N is 5, and we have 5 petals because it's odd, so it's exactly the same. This is still my A value. Now on this particular one, it's sine, we know it is because they told us, but there's another way to look at that. And I know it's on the positive y-axis, but it's not always going to be that way because if you look at this one, this is on the positive y-axis, but this is cosine. So we look at 0. There's no petal there. The first petal I come to is right here in the first quadrant. That's how I know it's sine. Okay? Does that help? All right, so that means then when I count 1, 2, 3, 4, R equals 4 sine 5 theta. Any questions at all? Okie dokie. So then, get to this one. Here, N is 4. We have 8 petals. We had to double it because it was even. I look at 0. I have a petal on the x-axis. That's what tells me that it's cosine. Okay? And then this is still A, and that's 4. So R equals 4 cosine 4 theta. What questions do you have? Ask me questions.
How do you find the N?
It's the number right before theta. Always. Okay? Anything else? All right. So now let's look at the only one that has a squared in it. These are limniscates. It's not a limniscate. It's a limniscate, like limp biscuit. Okay? Kind of think about the same little voice pattern there. All right, so limniscates. The only one with the R squared, so they're usually pretty easy to identify. It's kind of like a 2-petal rose, but you don't really have a 2-petal rose. You have a limniscate. Okay? That's the way it works. Again, you still look at that petal. So I have that first petal here. It's on the x-axis, so it's cosine. Nothing on the x-axis. It's in the first quadrant. That's what makes it sine. If I made this negative a squared, then it would rotate it to where it looks like this, where it would kind of make you want to think it's sine, but it's not. So you have to think about it when it's positive. And then if this one was negative, it would reflect over here. Okay? It would still be in the other quadrants. So since this right here, this is A, and in this case it's 1, 2, 3, 4. This is R squared equals A squared times cosine of 2 theta, so then R squared equals 16 times cosine of 2 theta. And it's always 2 theta. That number doesn't change for the limniscates.
How do you get 16?
Because it's A squared. This is 4, so I squared it and got 16. Okay. Oh, I have a question? Oh, I'm sorry. Where it like doesn't touch right there? No, because see how this one's, I don't know, that must be like a printing error. No, I see what you're saying. I didn't even notice that because mine's so blurry. No, it actually connects like an infinity sign. Yeah, that's a good question. I didn't even notice that. And then, so this is A also. I count 1, 2, 3, 4. This is A squared, so I square it. R squared equals 16 times sine 2 theta. We good? What questions do we have? All right, so then last we have spiral of Archimedes. If you don't know who Archimedes is, he's a pretty cool dude. Philosopher, mathematician. So this one, r equals a theta plus b. It doesn't even have a sine or cosine in it. And b could be 0, so it could just be like r equals 4 theta or something like that. And these are spirals. We're not going to worry about writing an equation for these because these we're not going to look at very much. We are going to graph one of them later on, but I'll show you why we'll be able to graph it. We don't have to come up with an equation, okay? All right, any questions about any of this right now? So keep this handy. If it's on a piece of paper, keep your paper handy. If you have it digital, don't close it out because you're going to need to refer back to it to answer our next sets of questions. So let's go to this. The first thing we're going to do is use this, because we don't have these memorized, right? We're going to use this to be able to identify and classify these curves from just the equation. So when I look at number 1, r squared equals sine 2 theta. Well, guess what? There's only one set that has r squared in it, and that's the lemniscates, right? So that's all it's asking me for here. So my answer is lemniscate. I know it's not asking me this here, but would this particular one be laying down or diagonal? Diagonal, because it's sine. And what is the a value? 1, exactly, very good. All right, so then I look at number 2. I've got r equals 3 cosine 2 theta. Clearly not a lemniscate because it's no r squared. It's not a limison because there's no plus or minus. Can't be a circle because there's a number right here. So it has to be some sort of rose, right? And how many petals would this rose have? 4, okay? So this is 2. I'd have to double it because it's even. This is a 4-petal rose. All right, so then I look at number 3, and this has the plus or minus. There's only one set that has plus or minus. That's the Limisons, and that's the one you have to pay a little bit more attention to figure out specifically which one. So it's.
Miss, how many petals do you know? I mean, how do you know how many petals there are?
Because if this number is even, you double it. If this number is odd, it is what it is. So like if this was 5, I'd have a 5-petal rose. Since it's 2, I double it and get a 4-petal rose. Yes? Okay. All right, so I know that this is a limison, and in this case, this is A, this is B, so A is greater than B. Okay, thank you. Yes? Make sense? So then I'm going to look on here. All right, where I have 2 where A is greater than B. It's the dimpled limison and the convex limison. So then I have to kind of see, like, how much greater than B is it? Do you think it's dimpled or convex? Is A more than twice B? 4 is not more than 6, right? So it can't be convex. It has to be the dimpled limison. So then I have r equals 4 theta. It doesn't even have a sine or cosine in it. So then what is it? The spiral, yes. So this is the spiral of Archimedes. Oh, my handwriting's terrible. All right. Okay, so then number 5, I got a plus or minus again, so I'm back to that limison category. A is 2, B is 1. A is greater than B again. So it has to be one of the last 2. Is it dimpled or is it convex? Convex, because 2 is greater than or equal to 2, right? Because I'd have to double that. So this makes this a convex limison. So I have another plus or minus. I'm still in that limison category. Here, A equals B. If A equals B, what do I have? Cardioid. All right, so number 7, no more plus or minus, so I know I'm not in the Limison category. 2 sine 7 theta, what category does that put it in? A rose. How many petals would it have? 7, very good, because that's odd. So this is a 7-petal rose. Then 8, I'm back to a plus or minus, so I'm back in that Limison category. Here A is less than B, so what does that make it? A limison with an inner loop. And I'm going to write it as an inner loop limison because that's less words. It's the same thing. And it's not that many more words, but you can talk about it either way. All right, what questions do you have at this point? Do you see how to use this graphic organizer to help you? Okie dokie. And it really helps if you have all that stuff labeled on there that I gave you. So now we're going to sketch some of these. And by sketching, that means it's not a perfect graph. We are going to plot a couple points, but not as many as we did yesterday. We just did that to discover some stuff. So the first thing we need to do is decide on number 9, what type of curve is it? So here, A equals B. What does that make it? A cardioid. So I have a cardioid. So now I have a picture in my head about what it looks like. My maximum R value, that's the greatest R value you can have. That's where you have the A or the A plus B or whatever. So for the cardioid, that's 2 times A. A is 2, so that makes my maximum R value 4. So I know for the cardioid, I'm definitely going to have a point on the pole. This is sine. So the other point.
Can you explain the 4 again?
Yes, so on your graphic organizer, you have labeled that the maximum R value is 2 times A. A is 2, so I multiplied it by 2 to get 4. Does that help? Okay.
Maximum R value?
The maximum radius value you can have. These are R's, right?
Oh, okay, I see it.
So yeah, so this is your maximum R value right here. Does that help? Okay. So that means since it's sine, I'm either going up 4 or I'm going down 4. Since it's negative, I go down 4. 1, 2, 3, 4. So now this distance right here is 2 times A. I know that it's supposed to have a heart look, but I'm not just going to sketch it in right here. Plus, I got to make sure I don't draw it like that because that's totally not the kind of heart it looks like. I would like a couple of other things, but I don't want to just plot random points. I think I would like to know basically like my x-intercepts, right? I know it's going to have to come up some and then back down. If I knew where it came back down and crossed here, that would help. This is when theta is 0. So if theta equals 0, I want to figure out what the R value is there. I'm going to substitute it into this. So I'm going to get R equals 2 minus 2 times sine of 0. Well, what's the sine of 0? 0, right? So this whole thing zeroes out here and you get R equals 2. So when theta is 0, my R value is 2. I could substitute pi in, but I know this thing is symmetric, so if it's going to cross here, it's going to have to cross here. And remember, it's not a heart that looks like this. It's like a fat heart. So then we just do the best we can to...
0, R equals 0.
Right, it does. R equals 0. Oh, I'm sorry. You're right, it does not. R equals what? 2. Sorry about that. Thank you for fixing me. R equals 2. Your ordered pair is 2, 0. Thank you. So it's going to come up some. We don't know how much, and that's fine. It's a sketch. And then we just come out and make it... Oh, see, mine's not fat enough. It's probably easier to start from down here. I'm still making it pointy. See, it's hard. I know, it's hard not to make it a heart. I can't help it. 1, 2, 3, 4. There we go. Something like that. Mine's a little lopsided. It's fine. It's not an art class. Just as long as you get the idea, it's fine. Just try not to make it a pointy, pretty heart, because that's not our goal. Okay, we good so far? All right, let's look at number 10. What type of curve is this?
Is it the spiral?
It's not, the spiral doesn't even have sine or cosine in it, so no, I'm sorry, it's not a spiral, but thank you for participating. But I think I heard it on here, and I heard it a few in here. What is it? Circle. It's a circle. It's actually what we did yesterday. It was an easy one. My maximum R value, that's the diameter. Remember, R, it does mean radius, but it doesn't necessarily mean the radius of the circle. It means the R value on the graph. And so that maximum R value is 3 because we are tangent to the pole. Since it's cosine and it's positive, I go this way 3 to get my diameter there, and then I don't have to plot any other points, and I just do my best to make it look like a circle, or a close relative of a circle at least, and we're good. Okay. What questions do we have? All right. Let's look at number 11. R equals 5 sine 3 theta. So what is this thing? It's a rose. Very good. How many petals do we have? 3. So this is a 3-petal rose. My maximum R value is that A right there, so it's 5. If this was cosine, my first petal would be here. And I would probably start by graphing my first petal. It's sine, so my first petal is in the first quadrant. The good news is, in calculus, sometimes that's all you need to know. Okay, it's a rose, the petal's in the first quadrant, okay, and then you use whatever it is you need. But that's not always all what you need. So we do need to be able to think about what the graph really looks like. And so I could, but I don't know exactly where it is here without having to guess at some points or know some other things. So I'm not going to graph that one first. But I'm going to think about the overall picture. I know if there's one here, there'd be one here, and then the third one is down here. This would actually be the easiest one to graph first. Would you agree? Even though it's not like the first petal, it's fine. My maximum R value is 5, so I'm going to put 1, 2, 3, 4, 5. So I know I'm going to have a petal here. I also know that the other ones have to be evenly distributed. So I have to take my whole circle and divide it by 3. My whole circle is 2 pi. When I divide it by 3, I get 2 pi thirds. So that's how far apart they are from each other. Does that make sense to you? Okay, so if pi thirds, so let's just look at how much pi thirds is. Pi thirds is 1, 2, 3, 4 of these little sections, right? So from here, if I want to figure out where this one is, I go 1, 2, 3, 4 little sections. That's pi thirds. 1, 2, 3, 4 more. This is 2 pi thirds, and I'm 2 pi thirds away. Learn how to count on your circle and know how it's divided out. If I go the same way this way, right? How did I do that? Go 1, 2, 3, 4, then 1, 2, 3, 4, and I'm right there. It's 5 away because of this. These are evenly distributed. I don't know really how fat my petal's supposed to be, but it's fine. We're sketching. And it's curvy. Don't make it like pointy at the petal. Okay, something like that.
Can you explain what you mean by 2 pi over thirds?
Okay, so I know that there's 3 petals, so I know that I have to evenly distribute them. All the way around the circle is 2 pi. If I divide that into 3 pieces, I get 2 pi thirds. So I know they have to be a distance of 2 pi thirds or 120 degrees between each one of them. Does that help? I don't know who said that, so I can't tell if you're... Yes, we're good? Okay. You got through, yeah. All right, any other questions? Okay, so on your assignment today, you are going to have to identify them, kind of like we did at the beginning, like what's it called, have a graph and identify the equation like we've done, and so forth. You're not actually going to have to graph anything today, because I knew we weren't going to get through all of these graphs, but I wanted to get through a couple of them so you had the idea of that. You don't have to. We're going to finish graphing these tomorrow, and then tomorrow you're going to graph some, okay? So you have enough for what you need to get through your assignment that I gave you today, and then we'll graph a little bit tomorrow, okay? If you have any questions, let me know. We'll start here tomorrow. Make sure you're on time.